Titration is an analytical technique of determining the stress of an unknown solution, usually pressed in an aluminum flask by titrating the unknown solution with a known solution, usually placed in an duress. Add an indicator to the reaction mixture to indicate the end of the reaction based on the pH range at the end point. Typically, indicator work by changing the color or stress of a solution. The equilibrium point is the point in the titration at which the amounts of the two reactants are equal. The intensity of the analyte can be calculated from the volume of titrate used the endpoint. Then, redox titration is a type of titration. There also is a laboratory method used to determine the concentration of an analyte. It is based on the redox reaction between the analyte and the titrate, and occasionally a potentiometer or redox indicator may be included as part of the process. When we say that this titration is based on a redox reaction between the analyte and the titrate, we mean that the analyte and the titrate undergo a redox reaction together. Redox titration, as we know, are based on redox reaction, and a redox reaction is essentially an oxidation reduction reaction. How can we tell if a substance has been oxidized? If one of the following four possibilities occurs when we say that the substance has been oxidized: if the electrons of the substance are lost, if the substance is exposed to oxygen, if the hydrogen of a given substance is removed, and when the oxidation state of a substance increases. Then, how do we know if a substance has been reduced? When we can say the metal has reduced if any of the following four options are true: if metal accumulates electrons, if the metal is charged with hydrogen, if a given metal is dependent of oxygen, and when the oxidation state of a metal is reduced. In redox titration, electron transfer occurs between the analyte and the titrate.
Method: making 0.5 mol potassium iodide solution. Place a plastic weight boat onto the digital balance and zero the balance. Weigh out 8.3 gram of Ki powder into the weighing boat using a spatula. Carefully remove the weight boat from the scale and empty the powder into 100 cm cubic volumetric flask, using a funnel if necessary to ensure that no powder was lost. Lightly tap the bottom of the weight boat and scrape out any powder using a clean spatula. Ensure that the end of the spatula was also tapped on the inside of the funnel. Use a wash bottle of distilled water and carefully wash the inside of the funnel, weighing boat and spatula and into the volumetric flask. Continue to add distilled water to make the solution up to mark. Place a stopper on the volumetric flask containing the potassium iodide solution and invert several times to ensure the solution was homogeneous. Making 0.1 mol sodium thiosulfate solution. Place a plastic weighing boat onto the digital balance and zero the balance. Weighing out 6.2 gram of hydrate Na2S2O3 5H2O crystal into the weighing boat using a spatula. Carefully remove the weighing boat from the scale and pour the crystal into 250 cm cubic volumetric flask. Lightly tap the bottom of the weighing boat to ensure all crystal entered the flask. Use a wash bottle of distilled water and a dropper pipette and make the solution up to mark. Place a stopper in the volumetric flask containing the 0.1 mol sodium thiosulfate solution and invert it several times to ensure the solution was homogeneous.
Hello, my name is Sumiha Marina Shaza binti Zulkifli and my metric number is E20211-027. So in this project assignment, I will do my part on discuss on result and the observation. So titration describe a process where the concentration of unknown substance is determined by compare it with a solution that known concentration. The concept that makes titration possible is finding the equivalent point. and identifying when the quantity of unknown substance is equal to the quantity of the known substance.
This result shows how to make in 0.1 mole sodium thiosulfate solution. Next is we make a copper analyte. We transfer it to volatile flask and adding distilled water until achieve the calibratory mark. After we place a stopper on the volatile flask contain the copper analyte. We everted it several times to ensure the solution was homogeneous, and we then prepare the copper analyte solution. Next, we calculate to making 0.5 mole potassium iodide solution. On adding Ki or potassium iodine to copper 2 sulfate, aqueous iodine brown is formed together with copper iodine, which is white solid. On adding sodium thiosulfate from the burette, aqueous iodine is reacted with, so the brown solution fades to light brown. As we continue titration, we need to swirl the conical flask. As I calculate the theoretical volume for sodium thiosulfate, it requires 27.2 cm3. So next, on adding a starch solution, it reacts with the iodine remaining to form a blue-black solution, which is starch iodine complex. After that, we continue the titration and we swirl it. As we need the endpoint, we continue the titration until it achieves endpoint, which is the 1 drop of sodium thiosulfate that causes the suspension to turn from bluish to white. So after 3 trials, there is average result for sodium thiosulfate, which is 26.8 cm3.
Hi and Assalamualaikum. My name is Husna binti Samsul Kamal and my matrix number is E202110275515. My task in this group is about application on redox titration. There are many application on redox titration, but on this slide we are focused on the 2 application on redox. First, I will explain about the redox titration in foods. Titration is an analytical technique widely used in the food industry. Allows food manufacturers to determine the amount of reagents in a sample. It also can be used to determine the level of salt or sugar in a product or the concentration of vitamin C or E, which affects the color of the products. For example, determination of salt in cheese and butter. Next, about redox titration in dentistry. In whitening, hydrogen or carbamide peroxide are the active ingredients in the bleaching agents. Their chemical composition is very similar, as carbamide peroxide breakdowns into hydrogen peroxide when applied to teeth. During a teeth whitening procedure, the hydrogen peroxide that oxidizes and breaks the chemical bonds of the chromogens, thereby dispersing their molecules. Because the spots are the result of chromogen accumulations, they appear lighter as they spread. That's all from me. Thank you.